So, as you may or may not know, I'm known as Eli the Computer Guy. I've been doing online technology education since 2009. I've been doing technology since 1996. And basically, I'm fascinated with the whole concept of free to the end user technology. What education? What if we could make technology education as accessible as running water? And that is basically the idea behind Silicon Dojo. So if you go to silicondojo.com, this is our platform. We have a platform. I mean, it's built on Wix, but it's still a platform. Anyways, if you come here, you can see all the different things that we do. We have the upcoming classes. So we have this class here. So we do Zoom classes. We do office hours. So the office hours are every Monday, 1 to 5 p.m. I get anywhere between 4 to 6 people to show up for those. Those are 30 minutes. And I'll talk with you about your specific issues and that type of thing. And we have the self-study program. So we have an introduction to Python. So if you're interested in this, so if you don't understand Python and all that, when I'm going through it, we have an introduction to Python. This is a 48-part series. We got about 500 people taking that. We have something called the Bottle Web App Framework. We have people taking that. And we have the introduction to SQL with SQLite. And we have a number of people taking that. And all of this is free to the end user. Basically, the idea, the concept, the theory. And it's probably a bad theory. It's probably a bad theory. But the idea is, what if we abstract the financial component from the actual educational component? So if you want to help fund this, you can click on the donor box link. You can click on the link here. And that will send you to this page. And you can then throw us some money every month. I do have to say, recurring tips are a nice thing. I can try to budget off of. But anyways. That's what's going on here. For anybody that's been following along at home, or following along as I do the different things, just so you know, I did spend a month in Miami. I like Miami. I like Miami. So I'm currently in Asheville, North Carolina, which is, I don't know, the dead end to your professional development, I guess is the best way to explain it. It's a beautiful mountain town. If you like beer and you like mountains, and you like sitting watching butterflies flit by, this is a great place. If you still actually are young enough to care about your career, not so much. So anyways, we went to Miami because we were interested in moving to Miami. So we actually spent a month in Miami. And I gotta say, I like me some Miami. Miami. It's impressive. I was pleasantly surprised about the technology stuff going on in Miami. I guess a lot of people, again, a lot of folks from the big cities still wanted to live in a city. Miami is still more affordable than a lot of the other big cities. So you have just this massive influx of tech people coming into Miami. That's just great. A lot of good people, a lot of interesting things going on. And again, you know how snarky I am about AI. You know how I feel about AI if you've been following along for a while. Holy shit, I went to this AI meetup. So they have this Miami AI meetup. And they had 3 presentations at the AI meetup. And let me tell you, the people knew what the hell they were talking about. They had interesting, innovative technology. They actually had a pretty good tech stack going on. It seemed like they actually had a damn business model. I was just in the back of the room oh my God. What? You mean you can make an AI product that isn't smoke and mirrors? So yeah, there's a lot of stuff going on in Miami. So there's a good chance we will be moving there. I'll keep you guys up to date with that. If we do move there, I would like to do more in-person things. Hopefully do this stuff in person. That's what I really want out of Silicon Dojo. I want it to be a much more in-person environment. I think we might be able to do that there. Cost of living, if you want to understand how idiotic the United States is right now, literally, Asheville, North Carolina, a redneck mountain town that is the end of your professional life, literally is cost comparative to South Beach. Not even Miami, South Beach. That is how screwed up our economy is. I don't know if we're in a recession. I don't know what the hell's going on. But when your little mountain town is as expensive as South Beach, I don't even know what to say. I don't even know what to say. So anyways, that's what's going on here. So we're going to be talking about MoonDream today. MoonDream AI. And to go back to my snarkiness, it's still not AI. It's still not artificial intelligence, but it is really useful. Oh, if you do have a question, forgot to say, if you do have a question, you go down to the React thing, you raise your hand in the Zoom call, and I will get to you just as soon as I have a moment. That's how I do questions. So anyways, we're going to be talking about MoonDream today. So MoonDream is really cool. So it's one of these new, again, AI, it's not AI, one of these quote-unquote AI models. But basically, it's for computer vision. Now, MoonDream's claim to fame is that it's really small. The idea is that it's supposed to be able to run on what are called edge devices, right? So edge devices are kind of things like Raspberry Pis or Raspberry Pi Zeros, basically low resource devices that you put at the edge of your network, and then you can give it some type of intelligence. Like basically you can load this model on, so you have Linux or whatever installed, you have Python installed, you load this model on, and now all of a sudden your little edge device, it might be running off of a solar panel, it might be running off of a battery, this little thing now has intelligence, now has computer vision. That is their claim to fame. Now, I can tell you, I did test this thing, on our world famous 2012 MacBook Pro. So these are the lab computers I had for Silicon Dojo when we were doing in-person classes here. These are 2012s. So these are, God, doesn't seem like it was that long ago. Anyways, these are 13-year-old computers. I think they're dual core, they're like Intel Duos or something like that. It's got 4 gigs of RAM. Anyways, it is an old-fashioned potato. I can tell you, I got MoonDream running off of these old potatoes with consistent results. The results were good quality. It was slow though. It was slow. Can a potato run MoonDream? Yes. Go have a cup of coffee, and then go kill a pig, and then go butcher the pig, and then turn the pig into bacon, and then cook your bacon, and then come back, and it might be ready for you. It was surprisingly slow. That I wasn't so shocked about. The fact that you can actually get MoonDream running on this old potato, actually I think is a pretty impressive thing, and so that on its own is fine. It's like, okay, so you got an edge device, you got a low power device, this thing runs on, it's slow, boo-hoo, whatever. The issue that I have though, my concern though with MoonDream and these models is that this thing right here is a 2023 M2 MacBook Pro with 32 gigs of RAM, blah, blah, blah. It's like the $3,500 version from, I don't know, a year and a half ago, maybe 2 years ago, I think about a year and a half ago at this point. And as you're going to see in the demos today, yeah, MoonDream isn't that fast. I mean, it's like on a 13-year-old computer, it's not that fast. You're like, what do you expect? It's a 13-year-old computer. On a $3,500 year-and-a-half-old computer, you're like, oh, okay, I do expect it to be a little faster than that. So that is one of the things to consider when you're using any of these products, is understanding how well it actually works. This whole thing, yeah, it's not running that fast, at least on this equipment. So anyways, so the idea is that it's supposed to be small. So these models are incredibly small. They're anywhere between like 500 megs in size to about 2 gigs in size. So you should be able to run these on the IoT devices. How well that actually works for you in your particular situation, who the hell knows? Again, go play, figure it out. The more interesting thing that I find with this is if you look at this, see what this is? See this little red box around the car? This is something called a bounding box, right? And so if you've watched, or if you've gone through my OpenCV classes, you all know how I like my bounding boxes. And basically what a bounding box is where it is your computer vision product, framework, or whatever can basically figure out where an object is. It then figures out the height and the width of the object, and then you're able to do something like a bounding box around it. Why that's valuable is with these models, many times they'll tell you what is in an image, but they won't tell you the location of where it is in the image. The cool thing with MoonDream is it gives you the X, Y coordinates of the objects in the image, plus the height and width, and so then you can now have those numbers, and then you can start to do some interesting things with it, right? So basically, if I had a robot, so imagine I have a robot camera, right? If a car goes by, and I have a really fucking fast computer, not this thing, faster than this, right? Anyways, it can actually process the car going by. It will know the location of the car within the frame, and since it has those XY coordinates, it can then now move and track the car. So you can do some interesting stuff like that. So what I actually find more interesting about MoonDream, other than the other hoopla, is the fact that it gives you that XY coordinate. I think that can be very useful for a lot of projects. When you are running this, they do have an API. So if you just want to connect to an API, again, you have a potato. You have a potato like this. This is all you got. You don't want to run this on there locally. They do have an API, so you can actually connect to their systems. It's currently free, so you can play with it. Or what is more interesting, again, is running everything locally. That's what I'm going to be showing you how to do today. So if you can come here, again, oops, no, we don't do that. You come here. Get you some different information, right? So basically there's two models, just so you know when you're dealing with this, there's the two models. So there's the 2B version, so 1.6 billion parameters, quantized, so that basically means it's compressed. It takes 2 gigs of memory. It's supposed to be for servers, PC, and mobile. Again, I question that whole mobile thing very much. Currently, everything is CPU optimized. So they say GPU here, but apparently it's only CPU optimized, so hopefully once they get it ready for GPU, it'll run faster. And the better thing here, the cool thing here, is it's Apache 2.0 license. So this is an open source license. Always read your licensing, always read your terms of service, but the nice part about this is you should be able to implement this into your products with no issue. Right? They then have the MoonDream 0.5 billion parameter. Basically, this uses 1 gig of memory instead of 2. Basically, it's supposed to be used for mobile and edge devices, and you know, it exists. It exists. If you're going to be using MoonDream, I would argue you should start testing with the 2B model, and then if the 2B model works for you, then see what happens with the 0.5B. Like, the 0.5B works. I'm not going to be snarky about it. It does its job. It doesn't do the job very well. Then you see this int 8 and int 4. So this is quantized. This is basically, with these models, it's basically a compression, how they compress it. So the int 8 is the best. It's the largest, but it can be the slowest, most resource intensive. And then int 4 is more compressed. So if you want to use the best model, you do 2B, and then you do int 8, and that should be the best model for you. If you need the smallest model, you do 0.5 and int 4, and that will be the smallest model. And then your results will be whatever your results are. I am having issues extracting the GitHub download. Is anyone else having the same issue? I don't know. It's there. As long as it's on GitHub, my job is done. So this is a PDF. So the notes for today are in a PDF. The ODT, I'm using OpenOffice, just because it's open source. So I don't know if you have OpenOffice. Or is it OpenOffice or is it LibreOffice? Might be LibreOffice. Anyways, we can come here to Docs. When you come here to Docs, you can go to Quick Start. They give you a whole bunch of different information. So this is kind of interesting, just so you can come here. So they have a Cloud API. Again, the Cloud API, you can go and you can create an account. They'll give you an API key, and then they give you the code for how to connect to it. It's all pretty simple. We're going to be doing the local thing today. So you can click on local. All right, so when you click on local, it then give you a processor option. Right, I don't know if you can see that. All right, I'll say, so what processor are you going to use, CPU or a GPU? And they really only give you the option for CPU, so you can click on that. It'll give you the model. Do you want to use the 0.5 version or the 2B version? So you click on that, and then you want to do quantize. And this is weird. So int 8 is better than int 4, but they put int 8 over here, so then you got to do this. Anyways, you do that, and then they give you all this code. So basically you can copy this code, The big thing is you need to install MoonDream. So there's a module for MoonDream, a package for MoonDream. This is going to install a whole bunch of other things along with MoonDream, a lot of dependencies. And then you need to download the model. So on Hugging Face, they have this model, and that's one of the things is when you're up there and you say what you want, you may notice it says to be int 8. So when you're up here and you select to be int 8, then it pre-fills this in, and basically all you have to do is you either use wget or however you want to download it, and you just simply need to download that into whatever your working directory is going to be. So here we have the import MoonDream as MD, and then you're also going to need Pillow. So Pillow is a package for dealing with images. We're dealing with images, so you do need Pillow, and so from pill import image. Right? And we have all of this. So that is what we're going to be working through today. Any questions about MoonDream? I use Star Office. Does Star Office even exist? Any questions about MoonDream up until this point in time? No? Okay. So we're going to go here. Oh, I'm going to see if I can see what I'm seeing. Oh, what is the first? So we're going to go here. Oops. Ever had one of those days? No, not that. How do we get to another page? How do I go down? Next page. Anyways. Okay. So we did that. Next page. Okay. Well, this is doing some weird stuff. So the first thing we're going to do is auto-captions, right? So one of the cool things with MoonDream is basically you can just simply tell it to create a caption for you for an image. So I have this image here. It's a buddy of mine. She was shooting this gun, and so basically this is where it's going to spit out the caption. So basically, you can look at this, and you don't even put any query, like any real query into it at all. You just simply ask for the caption. MoonDream caption. So I'm gonna go. Okay. And this is what the code looks like in order to do this. All right, so basically with this, again, if we go back here, what we're going to end up doing is we are going to get the image, we're going to get the caption, and we're going to write this to an HTML page just to kind of show you how that'll work to an HTML document. So import MoonDream as MD from pill import image. Again, that's going to be pillow. Model equals, and then md.vl model equals, and so this is going to be the model that you're going to use. So here, I don't know, I'm using 2b int 4 because that's what I was downloading during testing, and so this is the model. This is where you specify the model you're going to use. I have this just commented out here. This is for the 5b model, or if you wanted to use that. Again, not particularly very good. Then you say where the picture is. So picture, when I do this, and you do this, image. So basically you're just going to say where the picture is. So I have an image folder, so this is going to be image2 img2.jpg. So this is the picture that we're going to be looking at. We're going to use image, so this is the function we got from Pillow. So image, we're going to open the picture. And then we're going to encode the picture using encode image. Then here is basically all that's required in order to create a caption. Caption equals model.caption, encoded image, and then you can either do short or the normal is the default. Right? So it can either be short or it can be longer, and that's basically the only options you have. And then here you can simply print caption, and then whatever the caption is. So caption, and when this comes back, this is going to come back as a dictionary. So caption, that's actually going to print the caption out on the screen. Jock comes, Jock goes. Where is Jock? Anyway, so if we go and we take a look at the image, so we go to image, and we go to image 2, and so okay, so this is the image 2. So this is Andre up in Raleigh, that's me, looking like a numbnut. We are now going to hit the run, and we are going to see how fast this goes. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Again, you're gonna see me do a lot of white boy dancing in this particular class today. Because the one thing MoonDream isn't is fast for whatever reason. And this is something that you really do have to consider when you start implementing these solutions into your products, is exactly how fast is it going to be. If you have 5 images to process, there we go, we'll get to it in a second. So caption, 2 men, one in a black hoodie and the other in a blue hoodie. And was I in a blue hoodie? I don't know. Yeah, I was in a blue hoodie. There we go. Okay. There we go. One in a black hoodie, one, let's see, with white lanyards in rustic wooden room with a brick wall and a window. All right, so basically you just want to create a caption relatively easily. That's how you can do it. If we go and we take a look at the actual results, we can see that this is the actual HTML page that got created. So this is now open up in Safari. You can see my goofy ass face and Andre, and then we can see down here 2 men, one in a black hoodie and the other in a blue hoodie, blase, 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 right? So it is able to see that it's 2 men, it's able to see that you're in the hoodies, the whole 9 yards. What's interesting though, is it actually can get more specific. So if we go here and default is normal. Well, we'll just put it in normal anyway, control. It'll actually give you additional information. Like normally it tells you like Google is actually in the lanyard. And then we dance. Yeah, here's the thing. If you're young, you're 18, you're 19, you're like, yeah, I want to be cool like a computer guy. You do have to understand, this is about how I spend 80% of my professional life. Dancing like a white boy do. You think I just do this for your entertainment? Au contraire. This is what I do as I wait for systems to do what the hell they're supposed to do. Come on now, a little faster, a little fast. Come on, come on. Give me what I want, computer. See, this is why I have so much time to think about things like swimming in bitches. You're like, well, why does Eli think about things like swimming in bitches? Well, because I'm sitting here waiting for this thing to do what it's doing. So what else are you going to do? You're like, huh, so Andrew Tate wants to dive into an Olympic-sized pool. Anyway, there. So that came out, as you saw that. It'll probably be easier to read here. So we can see it is much more specific at the normal length. The image shows 2 men standing side by side, possibly in a hallway or office setting. The man on the left is wearing a black hoodie and a lanyard with a white design, possibly a Google logo. The man on the right is wearing a blue hoodie and a lanyard with a white design, possibly a Google logo. Both men are smiling and it appear in friendly or professional relationships. Right? So basically if you do the caption, this is what you're going to get. The nice part about this is you don't have to add any additional queries and you do not have to worry about prompt engineering, because especially with MoonDream, prompting is a thing. One of the things I meant to tell you folks with this here is one of the options MoonDream has is supposed to be structured outputs. So when we talk about structured outputs, what that's supposed to be is that you can ask it a question and then it will return the answer in JSON or XML or CSV. Like one of the big issues you have with any of these AI products is you ask it a question and then it gives you a correct answer back, but how do you turn that into something a computer can actually use? Curiously enough, you're supposed to be able to get structured outputs out of MoonDream. I banged my head against the wall for about 3 hours yesterday trying to get it to output structured responses, and that did not work out very well. Maybe I wasn't prompting it properly, but one of the things you will find with MoonDream is the whole prompting. Prompting is interesting. Prompting is interesting. Okay. So the next one here is MoonDream Query. This is where we can actually ask a question, right? So I have an image here of a beach environment. And so one of the things I can say is this at the beach? answer only yes or no. You can say those types of things. You can ask it to explain what it's seen. You can ask it specific information. Are there people in this? So that's one of the things you need to be thinking about with any of these products. Is the product itself, who the hell cares? Right? MoonDream is worthless. MoonDream is worthless. What is valuable is figuring out how to use MoonDream in a product so you can do something useful with it. So again, imagine if you have a marketing department at your company. And the marketing department at your company, somebody gave them a digital camera back in 2000, and they've just been snapping 100 pictures a day for the past 25 years. And now one of the big problems we have, right, you have all this data, you have all these files, what the hell to do with it? So one of the things you can do is you can scan through and you can start asking for things. Like, does this image have people in it? And basically, if it has a person in it, you could store information to a database to say these images have people in it. Does this image have a dog in it? These images have dogs in it. Does this image have blah blah in it? Right? And so you can go through and you can create scripts to go through and scan through those 100,000 images to try to start categorizing them and do that type of thing. What is it with people today? Vlad comes, Vlad goes. Anyways, so this is query. Query is actually pretty darn simple too. All of this stuff is simple. Again, technology is simple. You just got to do it. Okay, so with this, again, for all these, you're going to import MoonDream as MD from pill, import image. We're going to do the model. So here I have int8. Again, you can see I was doing testing while I was doing all this stuff. So now I have int8. Why do I have int8? Because I was testing at the time. So that's what's here. I can also do the 5 if you want. So the picture, we're going to do image. So I'm just putting that folder. So I have an image folder. So img10. If we go here and we take a look at img10. Oops, that's not what we want. We want img. Oops. Okay, so we go and we take a look at IMG, and so this is a nice little beach setting here. So we come down here. So image equals, again, we're going to open the picture, and then we're going to encode the picture as we did before. Let's see here. Is this a beach scene? Answer yes. Yes or no. I find the quotation marks around it seem to do well. Anyway, so this is going to be what the query is. So answer equals model. So we do the query function, the encoded image, comma, whatever the query is, and the answer. See this? So basically, the answer is going to come back as an index here. So answer is going to equal model query, encoded image query, and then the index of answer. Then we're going to print out the query, and then we're going to print out what the answer is. And we run this. I do find when you want to give it image, img, png. Hold on. img, oh, it's JPEG. Sorry. So anyways, we're on that. One of the things I have found, when you want it to give it back a specific response, putting the specific responses within double quotation marks usually gives you better results than not. So we can say, is this a beach scene? Again, this is the weird thing with it. Like, they really focus on this being part of an embedded system, and it works pretty well, but it's slow. So we can see yes. So it gives us back yes. Right? I can say, oh, you can just do other things. How many people are in this picture? And this is where you can just do the query and basically ask it questions. And then do the dance. Do the dance. Have a smile on your face like a white boy after an orgasm. I was telling that story before. Anyways, do a little dance. 2, it says. Well, that's not correct. There's a lot more than 2 there. Oh, let's see here. So what can we do? One last one for the query. You can say, explain what is in this picture. Media, Giphy, media. Giphy, GIF. What the hell are you doing? Oh, yeah. Yeah, that's how I dance. That's how I dance. I learned how to dance from Vanilla Ice. Ice, baby. Remember when he was popular? I remember when he was popular. He was considered a rapper. Wonder how Ice-T felt about that. There we go. So gives you a lot. So answer. The image captures a lively beach scene at dusk with the sky painted in hues of orange and pink. The sandy beach is dotted with people, some strolling leisurely and others engaged in more active pursuits. In the background, a lifeguard tower stands tall, its red and white structure contrasting with the surrounding environment. Blase, blase. So that's pretty good. Again, that's the image. That's the... Oops. What the hell's going on? Anyways, that's the image we're talking about, and that was the description. So basically, you can get any of that. You can ask it a question and get back a yes/no response. You can ask it to count. You get back a number. You will get back a number. Or you can ask more descriptive things. And so that's one of the cool things with that whole query function, is you're able to do that type of deal. Then I think this is far more interesting, is the pointer. All right, so if I do this, so I have an image here, and basically this is where I tell you can get the XY coordinates for the objects. And again, with those XY coordinates, you can then trigger other events to occur. And so basically with this, I was asking, where are the people? So I said, I want to look for people and give me back the XY coordinates. This X here, this is where the people are. So basically, and you can even, I don't know if you can actually see, this person back here is in the dark. It could actually find that person and put an X on them. When we do these boundary box overlays, basically all I'm doing is I'm using CSS. So this image is within a div box, and then inside that div box, I put these other div boxes, and basically I just put an X within the div box, and that's what gives us those X's there. If we go, and this is the pointer. Oops. You're having one of those days. This is the pointer one, right? MoonDream pointer. Okay. So basically, if we look at this, same deal as we did before. We're importing MoonDream, we're importing Pill, we're using the model 2B and 4 because that's what we're using here. We're then going to bring in the image. So image 2, if we go over and take a look at image 2, JPEG. Okay, that's us. There's something else. Yeah, we'll just do image 2 for a second. Okay, so image 2 will be fine. Let's see, we say image, open the image, then we're going to encode the image like we do with all of these. We're then going to come down here, and basically we're going to put the query. So it seems like with the query, you're supposed to make it as short as possible. Cup, truck, car, people. seems to be what we're going for here with this. So basically we're going to do query equals people. Point result equals model dot point. So we're using the point function, recorded image, comma, query. And then we're going to get back the points. Point result equals points. The thing with this is that's actually coming back as a list. So the point result points, this is going to come back as a list. So you're going to have a list of the x, y coordinates for all the different objects that it detected, right? If we come down here, so let me just point, just so you can see that, print, I don't think that's there, print. Oh, no, that's, oh yeah, I'll show you that. Okay, so we're going to print this out. Sorry, print. We're going to print out the list here. Then, just to show you again how you can actually have like an output here, we're outputting to an HTML document. So with open MoonDream-point.html, W for write, we're going to create this div box. So position is relative. So whenever you're doing boundary boxes within divs with CSS, what's kind of weird is that the external, the outside div box, you give it a position of relative, and then inside you give the position of absolute. That's basically how it goes. So anyways, so we're going to create this div box on the outside. The height's going to be 400, width is going to be auto, it's going to be inline block. Basically just CSS here. Then we're going to do image src picture. We're going to make the height 100%, and the display is going to be block. Then what we're going to do here is we're going to do the points. So basically what this is setting up here is it's setting up the image itself. So we're going to have a div box around the image, and now we're going to plot the points within that box. So we're going to come down here. Now the thing is, when we get these points back, and you'll see this when we run it, the x, y values are between 0 to 1, right? So 0, 0.1, 0.255, point whatever. Right? So basically, it's between 0 and 100%. So one of the things you can do in CSS is you can either give a pixel number, how many pixels over, or you can give a percentage over. So what we're going to do is we're going to feed CSS the percent. So in order to get the value that we need to multiply this by 100. So point x, so for point in point results. So point results is a list. We're then going to iterate through that list. Point x times 100 is going to equal x. Point y times 100 is going to equal y. So if point x is 0.1, then we want to multiply that by 100, and that's going to get us to 10%. Right? We're going to print that out on the screen just so we can see it. And then what we're going to see here is basically with the coordinates, it's giving you from top, so x from top and y from left. So top, so y from top, x from left, x, y, right? So anyways, so y is going to be, so if 0.1 comes back, we multiply that by 100, that gives us 10%. That means 10% of the div box down is where the x is going to be. And then if we got like 0.25, we got 0.25 as x, we multiply that by 100, that'd be 25% from the left. Jocko, we'll get to you in a second. And then basically we close everything. So we put an x here, so this is where the x is, and make the color red so we can actually see it on the screen. So we're going to run this, and we're going to do a little dance. Oops. Jock, did your hand go down, or did your question get answered, Jock, or did your hand get tired? Yep. Wait a minute. Hold on. Fuck. Volume. Try again. Are you talking? Ah, shit. You seem to be talking. Oh, lordy. You're on one of those days. Sound. Yeah, where's my sound coming from? MacBook Pro speakers. Can I not hear you? That seems weird. Are you actually talking? Yeah. Oh, Well, I can hear him just fine. Well, good. Good for you. Good for you. Oh. Audio. Oh, okay. Speaker. Oh, speaker. Yeah. What the fuck? Same as system. Okay. Now try to talk, Jock.
Testing 1 2.
Hey,
Testing 1 2.
there. I know how to use a computer. Okay. Yeah. What's up, Jock? What's going on?
Okay. So for the coordinates you're putting in, and we're trying to get the XY coordinate, is just for the div box we created. It's not for the entire picture itself, correct?
Well, yeah. So what's going to happen, right? So we have wherever the hell my image is. I think this is the image we used, right? So we have my image. So basically, this image is going to be put within a div box, right? And then those X's are actually within their own div box. So we get this list back, right? So we get this list of dictionaries back, right? So X is at 0.35, Y is at 0.33, that's one value. X is at 0.71, Y is at 0.34, that's another value. So what we're going to do is for however many objects were detected, we're now going to start overlaying div boxes on top of this image, and that's going to give us the two X's here, right? So we multiply by 100, that gives us 35, 33, 71, 34, and then when we do the point, all right, so we come down here, we do the 4-point endpoint result, so that's where we're going to create these additional div boxes. And so when we then go to this, we can now see him, me, we got X in the middle of the head, right? And if you take a look at the very ugly HTML that's going to pop out, basically what you can see is, right, so we created this div box here, which is the relative. We put the image into that div box, and then see here's one X for div at the absolute position, top down 33%, left 35%, and then this is another top 34%, left 71%.
Okay, and that's for the entire picture itself.
Yeah.
So okay, I got another question.
Yeah.
So say for instance we want to. Could you go back to that second picture where we got the div boxes? That one right there. No, back. That one. So, say for instance we had we made the absolute div box. The absolute image is the absolute div box is the main picture, but we put a smaller div box in that picture. Can we, do an XY for the individual div boxes? And the only reason I asked that is because when we compare it to the CV version, and we did the eyes, like we did the code, it would give us like XY coordinates for the eyes and the nose in different div boxes. Kind of see what I'm saying? So you made one entire div box, and we put XY coordinates for you and your friend.
Yep.
But now if we want to make a smaller div box, can we do X and Y coordinates in the smaller div box? Say, for instance, your eyes, your nose, your mouth. Can we do that in MoonDream? You guys see the question I'm asking?
Yeah, well, so how this would generally work, you can make this really fucking complicated. But so we're going to get to bounding. So bounding boxes is the next thing. But yeah, so basically
okay.
With how this would be, is you would say, where are the faces? And essentially, if you might run it through a couple of times. Basically, you can ask it for eyeballs too. So you can say, give me faces and give me eyeballs. And then it would give you a list of all that. So I don't have it here. So it would give you
coordinates.
Yeah, give you all those coordinates. And then basically it would just, that's what I was showing you here. If you go to the source, then you can just have it create the div boxes. So like so again, you're dynamically creating these div boxes down here. So you could try to make the eyes different color. Again, how you stack all of this. Because what we're doing right now, so when I just say faces, right? So when I just say faces, it's just giving me the faces. So I could do multiple queries. I could say, give me the coordinates of faces in this image. If that does not come back as empty, ergo there are faces, then give me another result of eyeballs or smiles. And then what I could do is I could say, do a div box, do a square box around the face, make that red, and then with the CES, with the eyeballs, with those results that come back, make the eyeballs green. But that starts to get a lot more, because that's where basically, again, we're doing the four point and point results here. So point result comes back here. So I could do face point result with people, and I could say if face point is not empty, then run the next query for eyes, and then I could do eye underscore point result. And then what would happen down here is we would do 4 point and point result, and this would be the faces. And then underneath this, before we close out the div, I would then do 4 eye in eye point result, with the difference being the color would be green or whatever. And then it starts to become a mess, but it's functional. It's just ugly as hell. And basically what you're doing, you're just layering just a crap ton of div boxes on top.
Yeah. So, I mean, we used it for face, but like in the previous image on the beach, you're trying to, so say for instance, you're trying to find a specific image on the beach, say like a book or whatever. So, yeah, but like you had a whole bunch of things in that image, but you say like, okay, I'm trying to find the trash can in that image. But right now you got a whole bunch of things, and then you got to isolate the people, then you got to isolate the building, and you say, okay, there's a trash can, but you have to create those div boxes and scale down, scale down, scale down, scale down. Kind of like if-else statements, what it sounds like you're making. So you're continuously going through scaling image smaller and smaller and smaller until you come across the thing that's can be identified as the kind of garbage can in a bigger image. Or like the image with you and your friend are scaling down like eyes, nose, mouth, and things like that. If that's empty, go to the next one. If that's empty, go to the next one, and so forth and so on.
Yeah, you can do that. Yeah. Or the other thing too, and that's where you get into real programming. Like, so let's say the face. So what if it detects eyeballs outside the face, right? That's a problem. Again, that's one of the problems you get into with OpenCV. And that's what OpenCV does, is it's like, if there's face, then within face, look for eyeball. So this doesn't give you that, right? You can look for a face, and you can look for an eyeball. Lord help you. Not showing you the code. What you could then do is you could have a list of eyeballs and a list of faces. And so basically, every time it iterates through the list of eyeballs, it could check to see if a coordinate for an eyeball is within the coordinates of a face. And if it is, then draw a green box, else dump it. Mm-hmm. And that's where I tell you, folks, that's why, again, this is why this is so true. This is why 90% of our work is done on whiteboards and 10% is done on the computer screen. Because like that's the kind of, like, you've got to figure out logically how to get to whatever it is you're trying to accomplish.
Okay. And then even you can scale it even further. Well, I don't know if it does this, but like when you get to that part with the eyes, to see the color and being able to identify through the color. Like you're saying, you have 1,000 faces. Like people taking pictures of thousands of faces, but you want to isolate, once you get to that bounding box, okay, you got the face, you got the nose, you got the eyes, and then you get the color. And that's when you kind of like determine even more. All right, that's kind of like what I was asking.
Yeah, I mean, that's all, like, when you get to that, like, I don't know how well MoonDream is what it is. Again, not being snarky about it, just fucking is what it is. That's where, again, you get into the whole coding thing, and what you might have to do is you might have to, because with OpenCV, one of the cool things with OpenCV is it's actually a whole computer vision suite. There's a whole bunch of stuff we didn't go over. I do want to go do a real class on at some point. But one of the things you can do is you can essentially auto-crop images. So God help you. Here's what you could do. You could pull out all of the eyeballs, and you could pull out all of the eyeballs that are within a face. Then what you could do is you could then feed all that information to OpenCV. OpenCV could then literally cut out the eyeballs from the thing. And then you take those new images. So it could turn every single eyeball into its own image. And then you could take that image and feed it back to something like MoonDream and ask, what is the color of the eyeball? Like, but again,
Okay.
yeah, that's where like, yeah.
Cool. Thanks.
Yep. So yeah, that's the whole, like with all this, again, it gets to like how much work do you want to do? How, again, like that's what I always tell with like when I used to have clients, right? It's the whole, it's not whether or not I can do it, it's essentially how much money are you giving me? How many resources are you giving me? So anyways, I just wanted to show you. So we have image, that beach image that we had before. And so instead of the two of us, basically I fed the beach image into this for the points, looked for people, it gives us this big old list. These are the coordinates for everybody that it sees. And so if we go over and we refresh this particular page, we can now get an idea at least of what MoonDream is seeing as people. And again, what's weird here is when I asked how many people was in this image before, I got 2. When we do the whole point thing, we can see it says 1, 2, 3, 4, 5, 6, and 7. So you do by points, you get 7. I will say an interesting thing, if you're exporting, just something for you to know. So I use the Apple ecosystem, obviously. I use iPhoto and all that. One of the interesting things that I found is when you export using JPEG, the image quality is actually quite dog crap. So if you're going to export images for these types of projects, try to export them as PNG files. The quality is much better, therefore MoonDream should work much better too. But anyways, that's basically the idea of how the point thing works. So you can ask it to look for a specific point. It will feed you out a list of dictionaries. Then once you have that, again, if you're going to do HTML or CSS, you multiply by 100. If not, you do whatever you want with those numbers. Let's see. Is everybody still following along? Any questions other than Jock? No? Okay, so then we're going to do bounding boxes. So again, so this is me and Andre here, and basically the idea is you put a bounding box. So before I put an X here, so now we're going to do bounding boxes. Again, using those divs. Basically pretty simple. Let's see here. Go take a look at the code. What did I name this code? Object. Anyways, let me just copy and paste this code. Not sure what happened to that in the file structure. Oh, golly. That did not work out how I thought it was going to work out. Hold on one second. Let me clean up this mess. Initialize the model. Alright, hopefully that's going to work out correctly. Okay, so basically what we're going to be doing here is we're going to be creating the div box. And again, like I say, all that is, or we're going to be creating the bounding box. All that is a div within CSS. So this is going to be one of the things you need to be thinking about. Again, we talk about with technology, there's 20 ways to skin a cat. Like there's different ways of doing things. So you can create these bounding boxes or you can create these X's using JavaScript. There's something called Canvas in JavaScript, so you could do it that way. Again, I like doing CSS just because it's relatively easy. Let's see here. So we have the same stuff as we had before. So MoonDream. We have pillow, model equals, so we're using 2B for and here. Image is going to be image2, JPEG. We're going to be opening it, we're going to be encoding it. We're then going to do a query for faces. So we're going to look specifically for faces. We're going to detect result equals model detect, encode image, detect result objects, right? So basically with this, it's going to come back as objects, and you're going to get both the x, y coordinates, and you're going to be getting the height width. Well, you get height width in a weird way. You get x minimum and x maximum. You get y minimum and y maximum, and then you have to do a little bit of math to get the height and the width there. So we take a look at this. So it'll detect the objects. We're going to print that out. So with open MoonDream object.html, write. We're going to write the div box on the outside. The position is going to be relative. It's going to be 400 pixels, auto inline block. We're then going to write here. We're going to put the picture in. The height is going to be 100%. It's going to be a block. And then here we're going to do for object in detect result objects. So this is going, again, it's going to come back as a list of dictionaries. When that list of dictionaries comes back, you're going to get your x, you're going to get your y, you're going to get your x minimum, you're going to get your x maximum, you're going to get your y minimum, you're going to get your y maximum. And so then we have to turn those numbers into something useful. Again, a lot of people ask like whether you need to be good with math to do coding or technology. And again, the reality is you don't need to do calculus and all that kind of stuff. You do need to be able to figure out this kind of level math to do a lot of stuff, right? So x equals object x min. So x min is going to be your x. Sorry, x min is going to be your x times 100. So basically, what this is going to do is it's going to give you across where the x starts across. Y object equals y min times 100, so that will give you where the y starts going down. Width equals, so object x max minus object x min times 100. So these are percentage values, so we're going to subtract the min from the max. That's going to give you a decimal point. We're going to multiply that by 100, and that's going to give us our width of the object. Height is going to be y max minus y min times 100, and that is going to give us the height of the object. So the xy coordinate will start basically at the beginning of the object, right? So from the top, from the left, x min, y min, that's where it's going to start. We're going to do this math here to figure out how far and how long it goes down. Let's see here. We're going to print out x and the width and y and the height. Let's see here. And so here, color red, position absolute, border, 2 pixels, solid red. So this is what's going to give us our border, that bounding box. Top will be y, left will be x. So from the top is the y, from the left is the x. Width is going to be width, height is going to be height. Then we're not going to put anything in the div box itself. We just want the div box, and then we're going to write to the screen. And hopefully, if I did all the indentations correctly, this will work. And then we do a dance. It works on edge devices. It's just slow. It's just so slow. Okay. So basically this spits out. Okay, so yeah. So here is the lists. So okay, so x min comes out at 0.60. Y min comes at 0.30. X max comes in at 0.86, Y max comes in at 0.67. So you get the minimum, you get the minimum, you get the maximum, you get the maximum. So the minimum is where it's going to be from the left. So X minimum is from the left, Y minimum is from the top. We do some math and we get down here. We can see 27% over, 20% down, or 27% over, 20% wide, 20% down, 39% high. Anyways, let's go take a look at the Oh, the document we created. MoonDream object. Uh-oh. There you go, now it fits his face. Oh, I did something here. This is what happens when you do live stuff. For object and detect objects. Did I forget a div somewhere? That's a div. Image. Alright, well, I have other things to show you folks, unfortunately. So, that's how it's supposed to work. I'm not sure what's going on with my code here. So, as you can see, my face has the div box around it, and that is working perfectly. The other div box is not working perfectly. Absolute. Oh, that's the problem. I added an additional div. Yeah, this is the thing. This is like, how did I add an additional div? Oh, that's how I fucked up. Do remember with loops and things, the indentation has to be correct. So the problem that I had there, where I screwed up, right? So when I copy and I pasted, it turned into a disaster. So I had to adjust the indentations. So the issue is when I adjusted the indentation, it closed this div, right? So we have the main div here, and the main div is not supposed to close until all the way down there. But because I created that loop, and I fucked up the indentation, basically what was happening is every time that loop ran, it was closing the additional div too, and that's what was causing the problem. So instead of the div closing down here like it was supposed to, the div was closing here, which then meant this div was just kind of flying all fancy free or whatever. There we go. So if you do the divs properly, then that's the solution that you get. And so anyway, so that's basically all we're talking about. We're talking about boundary boxes. So x0, y0, so forth and so forth. Any questions on the boundary boxes? No? Okay. Let's see here. The next thing then is this auto-caption project. So this is something, again, like, imagine, again, you have a whole bunch of images for whatever, just have whole piles of images, and you've got to start sorting them. It's called taxonomy. So whenever you deal with content management systems, you don't start dealing with these images. Basically, taxonomy is the text that you use to be able to try to interact with the image, right? So when I go to a computer, I can't simply query for hamburger or query for French fry. It doesn't know what this thing is. So what you do is you run these images through some kind of computer vision, and then you get it to auto tag. Right, so what I did is I went out and I just got a whole bunch of images for McDonald's and for Taco Bell and for Burger King, and then basically I had it auto tag or auto describe what is in these different images. We then dump that into a database. So that's one thing, again, to be thinking about with your systems. We start talking about things like architecture and all that. is understanding how the computer looks at stuff. So what we're going to do in this particular project, right? So you have all these images. You have these images. So what we're going to do is we're going to use a Python script, and we're going to use MoonDream. And basically, what's going to happen is it's going to go to each individual image. Is that on the screen? It's going to go to each. It's going to go to each individual image, right? It's going to go to the image. We're going to give it a query. Basically, we're going to say what the hell is in this image. Then what's going to happen is we have our SQL database over here. So the database, right? What does a database store? It stores records. Does not store the image. Again, there is a data type called blob. Don't do it. Don't do the blob. Anyways, so in this, we are going to have a table. That table is going to have a schema, and basically what the schema is going to be is what is the image name and what is the description. So what's going to happen is it's going to go to this image. We're going to save that into one column. Then we're going to get the description. We're going to save it in the next column. It's going to go to the next image, next image, next image, next image, right? So it's putting these image names in the first column. It's putting the descriptions in the second column. Then what's going to happen is we're going to create our little web app, right? So we're going to use Bottle, because Bottle is our friend. We're going to have a little search box up here. And then basically, then what's going to happen is we plug in whatever query is in the search box. We hit submit. That's then going to go to our SQL database. It's going to go through the table, and we're going to use a like statement. So like is basically a wildcard statement. And so what it's going to do is it's going to look for any query that with wildcards matches the query that we put in, right? And then what it's going to do is it's going to find those records, and what it'll do is it will then embed that image with the description underneath. It will embed the image with the description underneath, so on and so forth. So if you're looking for images with tacos, then it will show you all the images. It will not show you all the images with tacos. That's important to understand. It will show you all the images that have a taco in the description. People are showing up at 3:15. Fair enough. So anyways, for this, basically we use SQLite. So SQLite is the database system we use because it's dirt simple. Again, remember, absolutely no security. Be very, very careful how you use SQLite in the real world. No security at all, but incredibly simple. And we use the Bottle web app framework in order to make this into a web app. We take a look then. Basically, we've got two scripts in order to make this work. The first script is going to be the auto-captioning. So with this, we do the auto-captioning. MoonDream auto-caption.py. All right. So let's take a look at this, and it's about 31 lines of code. So we're going to need a few things here. Right, so basically import MoonDream as MD, import pillow for image. We're then going to import OS, so we can deal with getting a list of all the images in a directory, and then we're going to import SQLite. So basically what this is going to do is it is going to scan this directory of all the images that are in the directory, and then it's going to create auto captions for them. We're going to use the model to be int8 because that's what I did, and then we're going to do image list os.list directory, and we're going to do the pic directory. So here's the thing: I know all of the images that I put into this picture directory, so I know they're all good. I'm not using any try except statements in this code because I'm trying to keep it simple. But do realize if you try to use MoonDream against a doc file or against a folder or against something else, it's gonna fail. So again, in a quote-unquote production world, you would need to put some kind of failure system in for whatever. So again, maybe try except statement, that type of thing. Try to have MoonDream read it. If it fails, go on to the next one. Anyways, just pointing that out. We're going to print the image list that comes up, just so we know that we actually have the list there. We don't have run into any problems. Query. What is in this picture? Use as many proper nouns as possible. Be very descriptive. State any brands in the picture. So this is the query that I used. How well it works? Meh. Again, I don't know. You're using prompt engineering against like a toddler. But anyways, then we have this function here for insert. Again, if you're dealing with, if you know SQL, basically this is just an insert function. So insert, it's going to be the picture name and the answer. We're going to connect to the MoonDream auto-caption database. So we're just going to do that connection here. We're going to create this thing called a cursor. Again, this is all in SQL classes before. And then we're going to execute first. Here, I'm putting this create table if not exist. I'm just putting it here to be easy as far as coding is concerned. So basically, create table if it doesn't exist, image. And then we're going to say image as a text data type and description as a text data type. So again, one of the great things about SQLite, what makes it so useful, is simply calling a database creates the database. And then you put this SQL statement in there, and then you auto-create the table if it's not already there. And so it's just a great way of, again, basically having a very easy data store. Then we're going to do this execute here, insert into image, image, so the image name, description, values, question mark, and then we're going to simply put picture, so the picture value that comes in and the answer that comes in, we are going to commit, and then we're going to close the database. So if you do not commit, the SQL statement doesn't actually fire off, so we need to commit it, and we need to close. So this is what's going to insert that data into the database. Let's see here. So we create our image list here. And so what we're going to do down here is for pick in image list. Picture equals os path.join picture directory.pick. So this is a way to join the directory and the picture name together so you don't run into any weird operating system problems. Anyways, image equals, we're going to open the picture and we're going to encode the picture. Answer equals, again, query, encoded image, query, answer, right? So basically we're going to ask it the question, that we're going to get the answer back, then we simply print pick, we print the description, we print the answer that comes back, and then we use the insert function, so we go insert function, pick, answer, and that's going to get inserted into the database, right? Gets inserted into the database. If we go, where is this? MoonDream. New terminal app folder. So we're at MoonDream AI. Guess you understand how this works. So we do SQLite 3. What the hell did I call my own database? This is why MoonDream auto-caption. MoonDream auto-caption.py. Okay, so we do tables. Just make sure the table, oops, file is not a database. Oh, fuck. Anyways, tables. So again, we have the image table, so we know that's there. So what I can do is I can do select all from image. And so this is where you see, so again, this is the database table itself. So screenshot, blah, 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 2 tacos on a wooden table. Screenshot, blah, 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 McDonald's, French fries, ketchup, mayonnaise, mustard, and a bottle of milk. Screenshot, blah, 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 taco. Screenshot, blah, 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 burger, Coca-Cola, right? So this .png, these are the names of the images, and then these are the descriptions of the images. So with that, we can then go, and where's my other script? We can do the bottle script, search gallery. So this is our bottle script. So this is what creates the web application, right? So basically the script that I just showed you, you would fire off that script, it would go through, it would scan every image, it dumps all that information into the database file. The thing is, that takes a long time. Again, as you've seen me do the little white boy dance, imagine doing the white boy dance for 20 of those, or 50 of those, or 5,000 of those, right? So anyways, that's its own script. So the script we're going to use here is going to use bottle in order to create a web app. And so with this web app, what it's going to do, just so you can understand, so I'm going to run it, hit enter, And so these are all the different images, right? So I have tacos here, I have Coke here, I have hamburgers here, right? So let's say I just wanted a taco, so I can go up here. So you can see I can put taco here. I can hit submit, and then it only shows me, doesn't show me only things with a taco in it, it shows me only things that has taco in the description. If I do a burger, it'll then show me anything that has a burger in the description. Again, you'll notice things like Coca-Cola. Again, this is the kind of thing you need to be thinking about with AI. How is AI going to name things? That's not Coca-Cola, that's Coke, right? But if I put search in here and I do Coke, I'm going to get nothing because Coke isn't in any of the descriptions. If I put Coca, then we get two images that have Coca-Cola in it. And again, that's the kind of thing that you need to be thinking about as you start building these types of systems. So anyways, this is, again, the Bottle web app framework. If we take a look at it, we're going to, from Bottle, we're going to import run, route, static file. So you need to do static file. Since these files exist locally on the computer, you need a static file function in order to be able to present it for the web app, post, and request. SQLite 3, we're going to import OS. Picture dictionary here, or picture directory here is image food. So let's see, we'll just close this for a second for the search. So here, right here, is the static route, right? So whenever we have static files locally on the computer, do remember when you're using Bottle or any web app framework for Python, it's not like Apache or Nginx. Apache or Nginx, you just have a folder, away you go. Here, you actually have to do some code. So that's where you have this route for the static files. So define serve static, whatever the file name is, return a static file function, the name, and the root directory. So the root directory is image food. So basically the file name and the image food get smooshed together, and we'll actually be able to deliver those images for you. Again, it's important to understand if this isn't here, and I run this. Right, and we go back here, and I do taco again. Oh, bite me. Let's say I do fries. Anyways, they got cached. It got cached. Don't worry about it. Anyways, so if you're running into a problem where you have the files in a folder, but they're not being displayed, it's most likely you forgot to do the static file thing. So then, down here, we have @post for root and @route for root. So route for root is when you go to the root of this web application. So you go to 127.0.0.1, port 8080. So all the way down here is this run. So run host equals 127.0.0.1 at port 8080, right? So when you go to that route, we're then going to get this index function. We're going to say query equals request.forms.getQuery. So we have this form here, the form that was at the top. So if a query was submitted with that form, it will come here. Response equals search query. So whatever value comes in from that form is going to be sent to the search function, and the value is going to be sent up there. So we take a look at this particular function. So what we're going to do here is I'm going to print term out on the screen to make sure it's working. We're going to connect to the MoonDream auto-caption database. We're going to create the cursor. Then we're going to do query equals cursor.execute select all from image where description like question mark. So this is, you just put a question mark there. So like is the wildcard thing. Then we're going to put an F string. So we're going to say F string. The percentage signs basically mean any characters, right, before. So term, so this is the term that's coming in. So we're going to say anything in front of the term and then anything after the term. So again, especially when you're doing searching and you don't really know what the data looks like, you want to put some wildcards in there. So if I put in burger or fries or Coke or cola or whatever, basically as long as that is within the overall word, it's going to go through and it's going to look through all these records and it's going to see if that word or that part of the word is there. We're going to do response, query.fetchAll. So fetchAll is going to bring back all the values that match whatever comes back from that like statement. Simply going to print it out on the screen just so I know what's going on. We're going to close, and then we're going to return the response. So the response is going to come back, and then we're going to return the response. So we have the form up here. So form equals form action. So we're going to send this to root. So that's why we have post here. So post, whenever you have a form, it's a method called post. You send data using the post method. So we have post here. So we're going to send to this, basically, for the query so that we can get it. Method equals post. We're simply going to say what is a search term. So input type equals text, name equals query. So this comes from there. So when this gets submitted to here, this is going to be able to pull out that value. Then we have a submit button, then we close the form, then we put a line across the screen. Page here, I'm going to make it blank so that I can then build the page. So for image, comma, description in response. So we have response, I want the image value, and I want the description value. Image equals os.path, join the pic directory and the image so that we can do embedding. So image is going to come down here to image src. We're going to do page plus equals. So plus equals basically means take what page already is worth, add to it, and then make page worth that new thing that's been created. And so we're just going to have some stuff here in order to create these boxes and all that. Basically the fun CSS. This is why so many coders hate CSS. CSS is easy as long as you do it right. So anyways, we're going to create a div box. So again, when we're doing this, I'm creating all these different div boxes here. So again, it's for. So we're going to iterate through response. So every time we iterate through a value in response, we're going to create this div box. Height's going to be 400, width is going to be 200. Display is inline block. Why inline block is important? An inline block means that the blocks are going to be side to side. If you don't do this, it's not going to come into like a tiles on a page. It'll be all one on top of the other. Let's see, border, 2 pixels, solid black, display flex direction column, justify content, whole bunch of this stuff here, again, already in those blocks. Then we're going to do image, src, so the image. So this is going to be the embed. So we're going to embed the image. Style equals height auto, width is going to be 200 pixels. We're then going to do a line, and then we're going to do description. So we have the image that came in here. We're then going to join the file path for the image so that we can embed it. We're then going to embed the image, and then we're going to put a line, and we're going to do the description, right? So again, here's the 200 by 400 div box with a 2 pixel black solid line around it. We're then going to put the image inside. We are then going to do the descriptions there. Then we're going to close the div. Page is going to equal form. Then we put some of this additional stuff here. So div, style, display, flex, wrap, flex, start. We're going to put the page in there. Again, all this stuff with CSS. Oh, it starts to make your brain melt. So, okay, how do I explain this? So these div boxes are these div boxes. And so what I'm doing here is I'm putting all of those div boxes into a larger container div box so they have something to contain them, and it allows the whole wrapping and that kind of stuff to work out. We're then simply going to return page. So this page that we created, we're going to return it. That return is what gets us to this screen. So yeah, anyways. The database stuff and the MoonDream stuff is pretty easy. The CSS that'll bite you in the ass every damn time. But anyway, so that's what gives us this thing, right? So if I want, anything, again, with an onion in it. Oops, is it running? Got to make sure it's running. Anything with an onion in it, I hit submit. It will then show me anything that has an onion in it. Does everything other than the CSS make sense? I will take any question other than the CSS, because, oh, okay, I'll admit, CSS sucks. Oh, Jock, what's up?
Why do you need the second div box? The bigger one.
So the bigger one is the container for these. So, okay, so when you're lining, so how do I put this? So when you're creating div boxes generally will try to be they'll try to be one after the other, right? So just one and then the next one, you got to scroll down the screen, right? So basically, why you do the inline, but so doing the inline block will basically try to put the div boxes beside of each other. And why you do the larger div box is so that you have a container. So kind of like before, when we were doing the bounding boxes, or we're doing the X's, right? You have the larger div boxes container, and then those internal div boxes were within that. So think about this as just a functionally larger concept. So you have the larger container div box, and then within that larger container div box, we're now putting these divs in. Instead of putting them at X, Y coordinates, we're just putting them kind of side by side as a tile. Cool. Okay. Yeah, it's... they have similar game to learn CSS grids. Oh, here's a site that helped me learn Flexbox. Yeah, I learned CSS. It's a problem thing with what I do. You learn things, and then you have to go back and relearn things, and then if you don't put the comma in the right place. Again, CSS. Just to be clear, CSS is one of those things. If you do CSS every day, it will make sense after about a week. The issue is you've got to do everything fucking perfectly. And if you walk away from CSS for a while and you kind of sort of forget one thing, it's a bit of a disaster. Anyways, it's why ChatGPT is wonderful. Again, ChatGPT, it's not AI. It's still very useful though. Okay, any questions other than CSS? No? Okay, so we will get to the final one. Oh, and what is our final project? My brain is dead. Oh, yeah, this is my intruder detection. Hold on. Potty break. 1 second and I'll be back. This is really cool. So we're gonna create an intruder detection thing using MoonDream. The issue is I have to have my orange sweatshirt. There you go. Look at that. Yeah, you all didn't think this would ever happen again. He's in orange. Yep, I'm in orange. So we're doing an intruder detection thing. So one of the cool things, right, is again, you can ask MoonDream to look for something. Again, relatively specific. And then you can get a response back. And if you can have a response that your code can formulate, then you can trigger events to happen. So what I'm going to be doing today is we're going to do the intruder detection. If there is a person in the shot that's wearing an orange piece of clothing, we'll get a green background on my webpage. If there's a person without green clothing, you'll get a red background on the page. And if there's nobody, you'll get a gray background. And I know what some of you are thinking. You're thinking, who the hell cares? Great, you're gonna change the color of the background. But again, the important thing is I'm just making something occur because of the value they get back. Think about this. You could have a Raspberry Pi. If somebody's detected or whatever, I could connect this, I don't have it around, I could connect this to a relay. If somebody in the proper uniform walks in, I could have the lights in a warehouse turn on. if somebody walks into an environment that does not have an orange uniform on, I could have alarms sound. Again, one of the things to be thinking about, like in the world of security, is you don't necessarily need things to be perfect to be good deterrence. Deterrence is an amazing thing, right? So if somebody like just walks into an environment and they don't have a uniform on, and then just an alarm starts going off, that's enough to scare most people away. And the things to be thinking about, again, that's one of the things to be thinking about in like this IoT world. And again, in this intelligent type world, is how can we make systems that are more seamless? Where I don't necessarily need to put in a password. I don't necessarily need to jump through a lot of hoops, right? People that walk into an environment with a uniform, the door automatically unlocks. Again, if you have a relay, you can trigger something like a door unlocking. If the camera sees a person in an orange uniform, the door is simply unlocked. Think about how much security that adds in an environment like Asheville that has a horrible homeless population, right? The homeless population is just ridiculous. Again, we need to do something good with homeless people, but we're not doing it, right? Again, a door is unlocked and they walk in the door. So imagine if everybody in your company has uniforms on, anybody with a specific color uniform, they go to a door, it's automatically unlocked. Anybody else goes to the exact same door, the door is not unlocked. Again, that's the kind of thing to be considering with this cool stuff. So we have this. So we're gonna see how well this works. MoonDream C. So we're gonna run this. We're gonna see how it works. Come on. Okay. So we're using actually OpenCV with this, along with MoonDream. So OpenCV is going to take a picture of my webcam. Right? So I'm going to do this. So right now, come on. Please use blah blah. Image save, so it captured the image. Capture the image. Room is empty. Save. Oh, lordy. Where am I at? Vision alert. Oh. Man, what the hell is it looking at? What the hell? Oh, Apple products. God damn it. Apple products are a wee bit too creative. I think it's actually using my phone for this. So anyways, okay. In some ways that's easier. Alright, so it takes an image, it takes a second to process. It may not see me as a human being. It may not see me as a person. Okay, there we go. So it sees a person in orange, and therefore I get the green background. If I point up, so hopefully there's nobody on the ceiling. So it looks up, nobody on the ceiling, so it has a gray background. And now, I do this. And oh wow, that's a pretty good picture of me. And again, it takes a couple of seconds because it's a janky implementation. Come on. There we go. Now it gives a red, right? So a person without the orange gives red. So that's a basic idea of what's going on. And again, this is the real world of technology. So Apple has this continuum thing for being able to use your camera as a webcam. And anyways, that's what's going on there. Let me show you how this code works. Let me stop this code so it stops bugging me. I'll show you how this code works. Okay, so we have to import OpenCV in order to make this thing work. So we got to import MoonDream, got to import Pillow, import CV2. So CV2 is the OpenCV. That's what OpenCV is called. And then we're going to import time. So this is an interesting thing. So if you decide to do this project, The first issue that I was running into with the project is every time I took a picture from the webcam, the picture was incredibly dark. At first, I thought it was broken. At first, I didn't think there was anything there. And then you looked at it really hard. You could be like, oh no, I'm there. This is really hard to see. There's this weird thing with how OpenCV takes a picture, where if you put a delay in after this capture, I guess it gives it more time to actually create the picture, and so we'll get a better quality picture. That's one of the reasons that this script is a little slow, because I actually have to put in a 1-second delay every time it takes a picture. Just one of those weird quirks. So something to think about. So we're creating this camera function here. So define camera. So with OpenCV, when we do the video capture feature, 0 is normally the default camera. If you're using an M processor back, this might need to be 1. Just one of those weird things just to think about. So cap equals CV2, video capture, and then we're going to sleep. If not, cap is open. Basically, I can't open the webcam for some reason. Then we're going to create the frame and all that. Let's see here. CV2.IamWrite, captured image. So it's going to, IamWrite is going to create an image from the frame, from what gets read, and it's going to name it this. So it's simply going to be called captured image. That's one of the reasons this particular project is a little bit quirky, is I'm just reusing this name. So since I'm reusing the name, you run into the problem of sometimes it's processing off the old image. It's kind of wonky. So you may, if you're creating something like this, you may want to create a system where you create new images each time this runs, and then maybe have a self-cleaning routine to delete old images after a little while. That can be done. It's not too difficult, but it adds to the project. So anyways, so we're going to do captured underscore image.jpg from the frame, and then we're going to print image saved as captured image. Else, fail to grab frame. So again, you got a lot of else's here. If there's an issue, we're going to release OpenCV, we're going to release the webcam, or we're going to destroy the windows. Here we have the model. So model is 2b int 8. And so what we're doing here is we're doing a while true loop. So basically we're just going to keep looping through, and it's going to keep going until I tell it to stop. Color is going to equal nothing, answer is going to equal nothing, and then simply going to call the camera function. So I'm going to reset our variable values. I'm then going to call the camera function. It's going to take a camera from my webcam. It's going to save it as captured image.jpg so that I have something to deal with. Picture equals captured image.jpg. We're going to encode. We're going to encode as we've done a couple times before. And then we get this weird if-else statement. I don't know if this is the best way to say this. Again, that's students. Students, you figure out better ways to do things. Again, whenever you're doing if-else statements, sometimes you get done with the if-else statement. You're like, wow, I could have phrased that better. But anyways, so you have to understand how MoonDream works. MoonDream is great for what it's great for. So if you ask it pretty simple questions, it's okay. You start making it more complicated, it gets wonky, right? So what I wanted here with the query is I wanted, if person is wearing orange clothing, say good. So good, I can parse off. If person is not wearing orange clothing, say bad. And then if room is empty, say empty. Right, that's what I wanted. That's what I wanted. MoonDream ain't gonna give me what I want. So we get this weird thing of like, again, you gotta play with these prompts to figure out what it'll give you. And so what I found is if person is wearing orange clothing, say good, I can get that to work. And basically I wound up with else equals bad. So if clothing, good, good, anything else is bad. But I've got two other things, right? I've got whether there's a person in the room at all, and I've got whether the room is, empty. All right, so anyways, so answer, model.query, encode image, query is answer. So we're going to get the answer back. Then I'm going to do another query here. And that's how we're going to go through the if-else statement. Query 2, if there is no one in, say empty. So if there's an orange, person in orange clothing, say good. If there's no one, say empty. And then we get to this ugliness. So, if answer.strip. So we're using strip here. So strip is a method that gets rid of white space around a variable. So one of the weird things is, and this is where I ran into a problem, right? I say good or bad, right? I tell it, tell me bad. Again, it's MoonDream. You don't. What was it? Compliance? What is that? Where it does what you tell it to do, but not quite. The weird thing is it actually, when it returns space bad. So space bad is not the same as bad. So that's why I have to do the strip. If answer dot strip out the damn white space equals bad, right? So basically it's something other than the orange. We're going to redo the query. We're going to re-look at the image with query 2, right? So basically, is it empty? We're going to say if answer.strip equals empty, answer equals room is empty, color equals gray. Else, so the room is not empty, answer equals bad person in room, color equals red. And then down here we have else. So all right, we started with bad. So if it's bad, do this. Figure out if there's a person in the room, or if there's bad, if the room's empty, or if there's a bad person. Else, answer equals good person is in room, color equals green. That's where I'm saying we could have futzed with the if-else statement here. We could have done, if, right, good. So I could have started with if good, else something. Anyways, what I did. Print, result, answer. So we get that result out on the screen. And then with open vision alert HTML, WS file. So this meta tag right here, this is going to auto refresh the HTML page. I just do this because it's really simple. So it's going to auto refresh the page every 2 seconds. Body style, so we have an F string, body style, background color equals whatever color it is that we set. Image src equals that captured image, height of 300 pixels, width of auto, and that's what gives us our thing. Again, if I then run this, you can just see on this screen, so boom, so see image is saved. Oh, there we go, we just got some text here okay, good person's room. Oh, probably sees that. Go away. That's the thing you have to be careful about. Like, it sees orange and person, ergo good person is in the room. Good person is in the room. Oh, come on now. Okay, now I took a new picture. I'm not a good person. You don't know me. Bad person in the room. So anyways, so that's basically how it works. Again, when we start talking about things like lag and latency, that's where you run into these weird issues. So with this, and again, that's where this could theoretically get cleaned up. Every time we take a picture, it delays by 1 second. So every time it takes a picture, it delays by 1 second. So when you're going through here, it's going to take a picture. If it sees somebody in an orange clothing, then it's just going to go through and do the good person. But if it doesn't see, it sees bad, it's going to take the picture again. So we're going to now go from 1 second of latency to 2 seconds of latency. On top of that, you have OpenCV actually taking the image, and then you have MoonDream taking its good old sweet time to come up with an answer. And that's why all of a sudden you go from something that seems like it should be pretty quick to something that gets like 10 seconds of latency per every iteration of this thing. So anyways, that's the basic idea with that. So yeah, anyways, so that's a class. That is the class on MoonDream. That gives you some different things to play with. Questions, David? Yeah, David. What's up, David?
Hey guys. So the sleep one is to slow it down, but once it takes that first picture, so it takes a picture of you and you move the camera and it's still processing. Why isn't it take another picture? Is it going to have to wait till MoonDream gives the answer and then go to the next picture?
Yeah, so we got the while true loop, right? So the function call happens here. So this is where it takes the picture. So basically, no, anyways. Oh, did I lie to you? I lied to you. Never mind. There was not 2 seconds of latency. I'm sorry, no, it takes a picture here. We embed the image here. We ask the question from MoonDream here. So that's a level of latency. If we don't get what we want, then it's going to ask it again. So no, I'm sorry. Actually, no, we do only take the image once. The latency is actually then going to get wrapped up when we ask those questions. I was wrong.
Okay, gotcha. Thank you.
All right. Again, it's like imagine being a teacher. I always hear that from people. It's like, oh, those who can, do, and those who can't teach. It's like, oh God, have you ever actually tried to explain code before? It's like, you get lost in your own code. Okay, Jock, what's going on?
Is there any way to to decrease the latency? Is it more just the software, or are we running it on like a different, like if you ran it on a high end, like a newer Mac, that would decrease the latency, or that's just MoonDream, the code, and that's why I'm curious. Like, is it the hardware, or could we kind of like reduce it a little bit through the software?
Yeah, so mainly with most of this, it's the hardware. So the only thing that I can really tweak a lot here, as far as I know at this point, is the sleep thing. So again, I am adding 1 second of latency to every loop. Literally just adding it there. The rest of the slowdown here is basically we've got the encoding image. It takes takes a little bit, and then we have the query here. This is what takes so much time. That's again. Not being too snarky on MoonDream, I'm not exactly sure what's going on because I've used, there's something called Lava. Lava is another image model. You can use it with Olama. I like Olama. I've got to say, it just seems slow. I mean, this is an M2 Max with 32 gigs of RAM. It's only a year and a half old. It's not, right? And so I would think that better hardware would run this thing better, but for Christ's sakes, how much would that hardware cost? So yeah, as far as I can tell, this seems to be some kind of hardware bottleneck at my end. Again, the current version of MoonDream uses CPU, so CPU is going to be slower than GPU. So when they release their GPU version of this, it might or it might not really speed this up. So this does seem to be more of a hardware issue than anything else, as far as I understand.
Gotcha. Yeah. And I don't know if someone asked the question about is this just for static imaging, or does this work for like video imaging, like when capturing live video as well?
So they show examples. If you go to MoonDream or you look at, if you go to MoonDream, like with this, they show examples with video files. And so basically what happens with a video file is there's actually frames. So that's where you see with OpenCV, you grab a frame. So it's like a video file is like a whole bunch of pictures kind of stacked together and zipping by you. So you can grab a frame. So you can, and they have examples of this if you go play with it, you can run a video file through MoonDream, and it will go through frame by frame to give you this different type of information, and then you can build something on top of it. So technically, right, you should be able to do that with a live video feed. My question is this is so dog slow on this computer, I'm not sure what quality hardware you would need for it to actually perform at the speed that would be required. Right, because if I have a 1 minute video here and it takes 4 minutes to process, fine. But if I have a live stream, I can't have it taking 4 times as long as it takes for the live stream to come in. You get what I'm saying?
Yeah. Okay.
So
thanks.
Yep. So, dun, dun, dun. Is there a way to test where the bottleneck in the process may be occurring? I am sure there is. Sure there is. And you sit down and you test 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 and you try to figure it out. Yeah, I mean, it could be it doesn't particularly like Mac. Again, I'm not using a Windows machine here. Maybe if I was using a Windows machine, maybe there's something different that's going on with the thing. Again, using Linux, maybe there's something weird with Mac. You just gotta test and figure it out. Is buffering a stream possible with Python? Is buffering a stream possible? Well, so with OpenCV, fuck. So again, you have the frames coming through. All right, so if you deal with OpenCV, yeah. All right, so, right. So you see here, it's talking about frame. You're capturing a frame. So when you're dealing with a video stream, it still is able to grab those individual frames. So again, like when you use OpenCV for like the recognition that a face exists, not facial recognition, but what, right, not biometrics, but just the face, right? What it's doing is basically every time it goes through, it's grabbing a frame, it's detecting whether or not something looks like a face is in the screen, and then it's giving you the X, Y, and the height, width, and all that, and then it's automatically putting the bounding boxes over it. So, and then once it's done that, it's then outputting that out to the screen generally. So, I mean, theoretically, what you would be able to do if you want to buffer is you could have the video feed come in. You could try to like rename the frames. So this frame comes in as frame 1, the next frame comes in as frame 2, the next frame comes in as frame 3. And then basically you could have those frames be read, the information could get pulled, and then down where you go to display the OpenCV output, you could try to be displaying like 10 frames back. On a very whiteboard level, that should work. That sounds like it'll work on the whiteboard. I'm not sure I want to write that code. But yeah, you should. So it's not really that Python would buffer. Python isn't going to be doing the buffering. OpenCV or some kind of framework like that would actually be doing the buffering. And then you use Python to basically do the configurations to make it work out. I don't know. I'd put $5 on the table. You could create a buffering system with OpenCV. Again, you run into some curious issues. Test. Just a thought. I heard that you can use Mojo to get C-like performance using similar like Python code. Yeah, I don't know. Maybe. That is great for anybody else in the audience. Again, one thing to understand with me doing all these tech education classes is I only have so many hours in the day and so many brain cells. So I get a lot of that question sometimes, like, oh, why don't you use this other framework? Or why don't you use these other things? It's like, because I have other stuff I have to do. So I find interesting, basically when I'm teaching you folks things, the main thing that I'm trying to get across is I'm trying to find interesting products that you could or can actually put into production that solve things in interesting ways to make you think about things more. Again, like with this, like with MoonDream will be great for prototyping, right? If you're trying to, again, like with that security thing I was showing you, wherever that is, right? If you're trying to figure out like a computer vision security system, MoonDream is an excellent way to prototype, right? And then show the boss or whatever how this thing would work. And then once you get the big ass check, then you probably want to go off and find a different product, right? So anyways. It's a superset of Python, but there's more to learn. Yeah. Oh, let's see here. Questions. New message. OpenAI is actually offering up to 11 million free tokens per day on the API until April 30th. So you can use image models and LLMs for free as long as you share the completions with them. Well, fair enough. I would be curious with their vision model, again, if they give that XY coordinate. And the other nice part about this, too, with the MoonDream, is again, it is all local. Like that again, that's where again with any of these technology projects, there's all these trade-offs. It's like, oh, right, OpenAI is so much better. It probably is, right? But you have to be online the entire time. If your network connection drops, it fails, right? So again, like let's say you put in a computer vision security system and the internet goes out. Does that mean your entire security system goes offline? That would suck. So again, those are kind of like the give and takes. Again, there's the important thing to understand as being a technology professional is there's rarely any wrong answers or even any right answers. It's just the answer that seems most appropriate at the time. Any other questions? No questions? Time to put your hand up. I'm going to go have a cup of coffee. Ooh, 4:03. It is coffee time, not beer time. I haven't had a beer since like October, but coffee time. Oh, I am proof too. While I was in Miami, that's right. I hit 173 pounds. So all those people out there saying you can't lose weight by eating better and exercising more. I lost whatever that is, 45 pounds since May. I started May 12th of 2024. I started losing weight, and by eating better and exercising more, and lost 45 pounds in less than a year. So, and part of that is not drinking beer. Beer is like 300. Like a good microbrew, you do realize that's like 300 calories a pint. When I go out, when I run 6 miles in the morning, I burn off like 700 calories. So if you have 3 pints of good microbrew, that basically means you got to go out and run 9 miles. 9. Just gonna put it out there. Every pint of microbrew, you gotta run 3 miles. Is it worth it? Okay. 45 pounds or beer. Tough decision. Yeah. I don't know. I have a family. Most of my family's dead. Most of my family's dead. And a lot of it came from health issues. A lot of it. I remember my step grandfather, or not my step grandfather, my stepfather. He was a Navy guy, right? And the reason he was in the Navy, it's no joke. He was in front of the judge. He was in front of the judge after getting arrested for about the 5th time. And the judge literally told him, the government is going to own your ass one way or the other. You can either make something of your life by going to the Navy, or you're going straight to jail. Pick. Again, a different time period. Anyways, he was like man's man, right? And yeah, it was, when I was young, and he was like, you know what? If eating sticks and twigs means I live like an extra year, I'd rather have steak. And the interesting thing, the lived experience about my life is I get to see how that shit goes sideways. Because you don't get that option. And at 43 years old, that blood vessel went pop, and he died. So anyways, that's what I kind of think. Because again, like everybody thinks that's a joke. Like even here, like in Asheville. So I'm part of I go to this meetup called Meet the Geeks. And two of the board members had heart attacks within a year. And one of them, guess what? Didn't live. It was like, what happened to what's his name? I was like, what happened? Like, heart attack. Died. Dead. So anyways, it's not really that, is it 45 pounds or beer? It's, healthy body. But you do you. You do you. I don't care what you do. I'm just telling you what I do. Oh, anyways. Yeah, beer doesn't sound great after that story. Yeah. It was so funny though. Like I said, growing up, I mean, he'd sit there, he's smoking the cigarettes. He was a Navy guy, right? He went into the Navy when he could still beat the shit out of the younger people. Again, that's how things have changed. Like when he started the Navy, if a younger seaman or whatever gave he was a senior chief when he retired. If a younger seaman gave like a senior chief bullshit, they could literally just fucking cold cock their asses. He was man. And yeah, he was always like, I'm not going to eat those sticks and twigs. Yeah, I guess you're not. Anyways. Okay, no questions? No more questions. Cool. Okay, so I'm back here in Asheville for a while, for the foreseeable. Again, we probably are going to be moving to Miami. That's going to be its own idiocy, but that'll probably be in a number of months at the soonest. So I'm going to be working on more self-study classes, again, for Silicon Dojo. Again, if you want to learn more about this kind of thing, again, with the Python and all that, again, 48-part Python series here. God knows, Bottle Web Apps. This is the web app framework, and this is SQL, Structured Query Language Database. So this is all the stuff that we dealt with today. So that's all there. And again, on Mondays from 1 to 5, I do the office hours. And yeah, that's all I got. Questions? No questions. Okay, folks. See y'all later.